Hello friends, welcome back to CAD practice. Today we are going to construct a 3D model of suspension assembly or a suspension system in Autodesk Inventor software. In this tutorial we are going to make this suspension system with the help of different components. So we have four components here: this top plate, bottom plate, this connecting pin, the red part, and the spring. Okay, so here first we will make all the parts one by one and then we will assemble them. Okay, so let's get started. First we will start with the bottom plate. Okay, so go to new, take a standard part in millimeter and go to create. Now take a 2D sketch and select the exact plane, rotate the view. Take the circle command from the center point, make a circle here, go to dimension, define this dimension as 180 mm. Okay, now go to 3D model, take extrude. Here we are taking an extrude of 10 mm. The direction will be direction 1 or only one side direction, and okay. Now select this top face, go to create sketch, and here take the circle command. From here make a circle of diameter 17.5 mm. Go to dimension from this center point and this center point, so this will be a dimension of 72.5 mm. Okay, now go to vertical constraint, select this point and select this point. Okay, now go to 3D model, take extrude, and here go to cut, and here take a cut of 2 mm. Okay, and press OK. Now we have a whole profile this side. Rotate the profile. This side we want a countersunk hole. Okay, for clamping the pin profile. So for that, rotate the profile. Select this back face. Go to create sketch. Go to view, visual style. Change it to wireframe. Now go to sketch. Go to project geometry and project this circle. Now escape. Select this. Make it construction geometry. Now go to view, visual style, change back to shaded with edges. Now go to 3D model, take here whole command. Here we are going to take the countersunk. So here the seat we will take countersunk. Okay, and here we will take tabbed hole. Okay, so here we will take isometric profile. Size will be 5 and the design will be M5 into 0.8. 0.8 will be the pitch of the thread. It will be class 6H, right hand direction thread. Okay, so here we have other dimensions. So this profile will be a countersunk of 9.5. So this will be a after the top dia after 90 degree. The depth will be 14.2 and just click this point. Okay, and press OK. So here the countersunk will be applied. Okay, when you zoom it, you can see the thread profile. These are the cosmetic threads. Okay, by the software, it will be automatically made. Now, we want to pattern both the profiles. So to make a pattern of this, go to circular pattern, select extrude to the bottom profile, the cut profile, and hole 1. Go to rotation axis, select this outer profile, and here we are going to take a count of 8 and press OK. Okay, now rotate. So this will be the profile, final profile. Okay, now we want this side a counter bore, sorry. So when I double click this, now here you can see the counter bore. This is from this end, the counter bore profile. Here we have also have a seat. Okay, so go to part 1, select, rotate this. From this side we will apply the counter bore. Select this face, go to create sketch. Take the point command as we are using the whole command. So we will take the point, go to dimension, define this dimension from center point as 30 mm. Okay. Now go to horizontal constraint. Okay, it is top view has been rotated. Rotate it. Now take the horizontal constraint, or here it is changed to vertical. Go to vertical constraint, select this and select this. Okay. Now escape. If top view has been rotated, then constraints will reverse. Now go to finish and take whole command. Here we are going to take the counter bore. Here it is counter bore. The seat will change to counter bore of M5, and here the top seat dia will be of 10 mm. Okay, and this depth will be of 5.4 mm. Okay, this total height of 14.2. Okay, and press OK. Okay, so zoom it. You can see the counter bore profile. Okay, now here we want a pattern of this also. So go to circular pattern once again. Select hold 2. Go to rotation axis and select this outer profile. Here we are going to make a placement of 6 and press OK. Okay. So this will be the bottom profile or the bottom plate. Now from here we will define the appearance. I'll give it a chrome polished. Okay, and save it. Suspension system folder. Make a new folder of assembly, and here we will name it as bottom plate. Okay, and save it. Now we are going to make the second part. So that will be the top plate. Go to assembly, return to assembly, double click this. So this will be the top plate. Okay, so the profiles will be matching, but this cut profiles and other things will be changed. Okay, back to the assembly. So go to new, take a standard part in millimeter and go to create. Now take the 2D sketch, select this XZ plane, rotate, take the circle command, select the center point, and here make a dia of 180 mm. From this same center point, make one dia of 50 mm. Okay, go to 3D model, take extrude, select this profile, and here take a 10 mm extrude and press OK. Now select this top face, go to create sketch, rotate the profile, go to circle command, make a circle here of diameter 17.5 mm, go to dimension. From center point, the center point of this circle will be at a distance of 72.5 mm. Okay, now go to horizontal constraint, select this point and select this point. Okay, now go to 3D model, take extrude, flip the direction to cut and take a cut depth of 2 mm and press OK. Okay, now the same process of countersunk we will do. So rotate, select this face, go to create sketch, rotate it, and here go to project geometry and project this circle. Okay, so here you can see the circle profile. Now escape. Now select the circle, make it construction geometry. Now finish sketch. Now go to the whole command. Here we will take the countersunk. So here we will change the seat to countersink 5 mm, and here we will change this to 9.5 mm. Okay, so the rest things will be same. Select this point for placement of this hole and press OK. Okay, now go to the circular pattern, select extrude 2 and hole 1. Okay, So we have selected both these profiles. Go to rotation axis, select this for rotation axis, the count of 8 and press OK. Okay, till here the profile was almost similar to the previously made. Okay, so now the next thing which we have to do is the cut profile. Go to assembly. Here you can see a cut profile. This profile will be at the side of the countersink profile. Okay, the countersink face. Select this face, go to create sketch, take the circle command from the center point, make one circle of diameter 75 mm, go to 3D model, take extrude, and here take a depth of cut will be 5 mm, rotate the view, and here take cut, and flip the direction and press OK. Okay, now select this face once again, go to create sketch. Now from here we will take the center to center slot, select this point and select this point, make one slot profile, and here make one more slot profile and escape. Okay, so go to coincident constraint, select center point of this slot, the vertical slot, and click on the center point. Similarly, select this center point of the horizontal slot and select this point. Okay, now escape. Now go to equal constraint from here, select this radius and select this radius. So both the slots will be equal with respect to width. Now go to equal constraint once again, select this center point of slot and this center point. Okay, now they will be equal in this length also. Go to dimension, define this width here of 6 mm. Okay, and this center to center distance will be 120. Okay, now you can see both the slots have been constrained at once. Now escape, go to 3D model, take extrude, select both the profiles, take here cut, the depth of cut will be same 5 mm and press OK. Okay, so this will be the profile. Now you can save it. First assign here the chrome polish finish, chrome polish, and save it. Save it as top plate and save. Okay, now go to new, go to standard part. Now we are going to make this pin part. Okay, for resting of spring or mounting of spring, go to 2D sketch, select the front plane, the XY plane. Okay, and here go to line command. From this center point, construct a straight line and make one line here, here, this, and this. Okay, go to dimension, define this total height of 13 mm, this width of 8.75, this will be 5, and this width of 6 mm, and this height here of 8 mm. Okay, now finish sketch, go to revolve command, select this as axis of rotation and press OK. Okay, now select this top edge, take the chamfer command. Here we will change the chamfer distance to 0.5 mm, select this edge and select this edge and press OK. Okay, exit this. Now select this top face, go to create sketch, take the circle command. From the center point, make a circle of diameter 5, go to 3D model, take extrude, select this inner circle of diameter 5 and flip the direction to cut. Here the cut depth will be 10 mm and press OK. Okay, rotate the profile. So this will be the cut. Now we will assign the appearance. From here we will take the red color. So here we will take light red. Okay, and save it. Save it as pin and OK. Okay. So here now go to new. Now we are going to make the spring profile. Take the standard part in millimeter and go to create. Now take the 2D sketch and select this top plane, the exit plane. Rotate the view. Take the circle command from the center point. We are going to make a circle profile. Here make a circle of diameter 14.5 mm. Now finish sketch. Okay, we only want this base profile of 14.5. Now from here we will take this 3D sketch to make the helical curve and take helical curve. Select this center point and select this y plane and select this green line. Click here. Okay, till here it is clear. Now click here on helical curve. So this will be a variable helical curve. This will be a simple or a constant helical curve, and this will be variable helical curve. In this, the change is we can change the pitch at different locations or different rotations here. Okay, so the first pitch will be of 2 mm, revolution will be remain 0, and diameter of 14.5 mm. Okay, second pitch also 2, revolution will be 1, and dia remain 14.5 mm. Okay, now for next, click to add. Here pitch will be 5 and here revolution will be 2. Okay, and this will be constant 14.5 mm. Click to add. Pitch of 5, revolution will change to 8, so 8 number of revolutions will come, and the dia of 14.5 mm. Click to add. Now here we have one more, pitch of 5, revolution of 9, dia of 14.5. Add one more, this will be back to 2 mm, revolution 10, this will be 14.5. Click to add. Pitch of 2, this will be 11th revolution, and this 14.5 mm. Okay, now click here and click on apply. Exit. So here you can see the spiral profile. Here the pitch is till from here to here, the pitch will be 2 mm, this also 2 mm, and the middle pitch will be 5 mm. Okay, now finish sketch. Now we will make a new plane. So we are going to make a new plane at starting of this spiral or a helical curve. Go to plane, select this point and select this curve. Okay, now select this plane, go to create sketch. Here go to project geometry and project this point. Take this circle command. From this center point, make a circle of diameter 1.75 mm. Go to 3D model, take sweep, select this profile, go to path and select this curve. Rotate the view. So this will be spiral profile. Now press OK. So this will become the spring profile will be created. Now we don't want this plane one. Select this plane one, right click and turn off the visibility. Okay. Now turn off the visibility of this sketch one also. Turn off this visibility. Now we want to cut the top face and bottom face, as we want a flat profile of spring at top and bottom. So for bottom, go to origin and we'll select the exit plane. Go to create sketch. Take the circle command from the center point. Make a circle of diameter 20. Go to 3D model. Take extrude. Flip the direction to cut. And here you can see half of the spiral, the last coil will be cut, and press OK. Rotate the profile. So here you can see a flat face. Okay, so this will be the resting face. Similarly, we will do this side also. Okay, so here go to plane and take offset from plane. Select this top plane, the exit plane, and take here a height of 46 mm. Okay, go to front and press OK. I'll tell you from where I have taken the height. From here, go to 3D sketch, double click this, so it will activate it. Select this helical curve, right click and click edit helical curve. So here you can see the total height of the spring is 46 mm. So the 46 mm will be the center point height. Okay, press OK and finish. Okay, by reference of this I have taken a offset plane of 46 mm. Rotate the home, select this top plane, go to create sketch, select this circle command from the center point, make a die of 20, go to 3D model, take extrude, extrude it upside. Okay, and here we'll click on cut, flip the direction, so the top profile will be cut and press OK. Go to home. Now you can see the cut profile here. Now select plane 2, right click, turn off the visibility. Okay, so this will be the final spring profile. Now save it as spring. Okay, and save. So this was the part 4. Now from here we will define the appearance. From here you can give the appearance to blue wall paint glossy. Okay, and save. Now we have completed all the 4 parts, so we will make the assembly. So go to new. From here we will take assembly, the standard assembly in millimeter. Here you can see assembly. This was for part. Now go to create. Now go to place and here go to assembly folder. First we will place the bottom plate, open and place it over here. Okay, escape, rotate the view, go to view, visual style, change it to shaded with edges. Okay, so this will be like this. Now you can see it is in moving form, so we will constrain it. Open the origin of bottom plate 1. Okay, open origin of assembly. This is origin of assembly and this is origin of bottom plate. Go to assemble, take constraint, select YZ plane and YZ plane, apply, exit plane and exit plane. You can see the plate has been rotated. So click on flush and apply, XY plane and XY plane, back to mate and apply, exit. Now you can see it is not moving. Okay, if I'll take home, okay, go to front, rotate, and this will be the view in which you will work. Okay, go to view, visual style. Okay, shaded with edges. It is on already. Now we'll place the next part. So go to assemble, go to place, select the top plate, select this top plate, open and place it over here. Okay, now escape. Now here call the other 2 parts also. Go to place, select pin and select spring, open and place, escape. Now we will assemble first the pin part. So go to free rotation, select this pin, rotate it accordingly and escape. Go to constraint, select this inner face. Okay, now rotate the profile and select this face of pin. Okay, now you can see it is constrained with this face and apply. Now select the center axis and select center of 6 of this hole, click on aligned and apply. So this will be applied here, escape. So for spring open the origin of spring and open the origin of pin. Okay, open origin. Now go to constraint, select the pin origin and select this YZ plane, and here we'll select the YZ plane of the pin. Okay, so it will be aligned here. Apply. Now we'll take the next axis, the XY plane of pin and XY plane of the spring. You can flush or you can meet and apply. Exit. Okay, so two directions are been constrained. This direction is constrained and this direction is constrained for spring. Now go to constraint. Select this face of pin, rotate the view and select this face of spring. Rotate. Okay, and apply. Now exit. Now here we want a pin profile this side also. So first we will assemble this top plate. So go to free rotation, select this top plate, rotate the profile and exit, escape. Go to constraint, select this axis or and select this axis. Okay, and here apply. Okay, go to constraint once again, select this axis and select this axis, apply, exit. Now rotate it. Okay, now we want this pin profile this side also. First you can do one thing for freezing the rotation. Go to top plane origin. Okay, and here select the YZ plane of the assembly, constraint and YZ plane of top plane and apply, exit. Now go to place, select the pin profile, open and place it over here. Now escape, rotate the view. Now here go to constraint, select this face, rotate. Okay, we have taken, I think, correct face we have taken. Okay, and select this face. Okay, and apply. Now select this axis and select this axis of whole. Click on aligned and apply. Exit. Now we have only one movement left. This movement up and down. So go to constraint, select this face. Okay, rotate and select this face, the cutting face of spring and apply. Exit. Now you can see it has been completely assembled. Now no motion is been left. Okay. Now go to pattern profile. Select this spring, this pin and this bottom pin. Go to circular pattern. Go to this axis direction. Select this for axis. Here you can see a count of 4 and degree 90. We want to double this and half this. Okay. If you take a count of 8, then we will change the degree to 45. So it will fill the profiles. Okay. And press OK. Okay. So this will be the final profile. Rotate the view. So this is the final structure or the final assembly of suspension system in Autodesk Inventor. Okay. We are left with the bolting. So go to place. From here, go to place from content center. Okay. We want a countersunk. Here we are going to take a countersunk number of ISO. We will take ISO. Okay, Z series metric. Double click this and select this profile. Select this face. And here we'll click on insert multiple So it will select all and press OK. Okay, escape. Now here you can see one thing. When I am changing this, go to view, and here I'll cut the profile to half of YZ axis and press OK. When I cut it half, you can see the bolting is not proper. Okay, so select this, right click, and here change size. So here I will take M5 and the nominal length will be of 16. Click on replace all. Okay, drag this and apply. Now you can see the bolting is proper. Okay, exit. So if I see the all boltings are proper in manner. Okay, now go to assemble. Okay, go to view first, switch off this and section view. Okay, now you can see the proper facing is done. Now go to assemble. Now I want the same screw that side also. So here also I want this. So here go to plane, select this face, rotate the view and select this face. So a middle plane will be created. Now for this countersunk, go to mirror, and here I'll take all the profiles, second, third. Okay, all the profiles one by one I have taken. Okay, now go to mirror plane and select this mirror plane. Now you can see the countersunk will be applied this all also. Next and okay. Okay, so they are applied. Okay, so I think the now the suspension system is complete. You can hide this plane, select this plane one, right click and turn off the visibility. Okay, rotate. So this is the final outcome of suspension system. I hope you like the video. If you do that, please do hit like and subscribe the channel for more such videos. Thank you.